Hello, my name is Pelle Cockburn and I'm going to show you how you can call your C# code directly from Java. And you may have existing C# code and now you want to run it from some place where it only runs Java, for instance on Tomcat or something like that. So there are different options, different approaches. You can of course translate your code and run it. You can create a console application, you can create a service and have your C# code in the service. And then there's a manual JNI proxy or using a third-party library called JNI for net. So of course the best performance is when you rewrite your code in C#. You can use all the C# features. It's hard to maintain. Now you have two different places. You have basically the same functionality and there's a risk of introducing new defects. You have two places you have to maintain. A console application is easy to write. It's slow though. You have to create a new process every time you want to run your code. So basically you're passing in parameters to your process and you're using the input and output stream for your interface. A service implementation, it scales really well. You can have multiple simultaneous invocations. There are some security considerations though. You have to find out how do you authenticate your user. It's hard to deploy. Now you have to deal with IIS and installers for running your service. The manual JNI approach is really well performing. You can migrate it whichever way you want. You basically write in the C++ proxy yourself, but it does require some knowledge of C++ at JNI. It's not easy to do. And we have the third-party library JNI for net. And no C++ coding needed. You don't duplicate your code. Performance is acceptable, and the only downside is that you now need to deal with this third-party component. So let's dive into it and try the manual JNI proxy approach first. So first of all, let's create some C# code that we're going to call from Java eventually. And here I'm using Visual Studio 2012, the Express version that's freely available, as long as you don't make any money on what you make. And we're going to create a Visual C# class library. And let's create a separate folder for those projects, JNI projects. And we'll call it Sharp Authenticator. And this project will just be, we'll imagine that we have a need to authenticate a user using the username and password. And so we'll just create an authenticator class. We'll make it public. And we'll have one method in there. Returns a boolean. So we'll return true if the username and password is what we expect, and we will return false otherwise. We'll take username and password as arguments, and for now let's just match two. Username is user and password is pass. In a real live implementation you would match those against the password against a hash in a database or something. Alright, so that's all for the C# code. So now let's create the Java code that we'll call the C# code, and I'm using Eclipse Juno. It's also freely available. You don't have to spend any money using a Java 8 IDE. And we have create a new workspace here, JNI example workspace. The workspace is basically just where you have your code. You can say each project you probably want to have a separate workspace. So let's go ahead and create a new, just ordinary Java project. And it's called Authenticator. And the default settings are fine. We'll create a class here, and it's always a good idea to use a package which is like a namespace in C#, and the convention to use the reverse of your company name, so company name domain. So we call Authenticator, and we'll add a main method we can call. So this is the way you create a console application in Java. And we need to call a native assembly. So we'll in the type constructor of this class, we will add a load library method to the assembly. So if the assembly is authenticator.dll, you just write authenticator, and then you have to declare the methods inside the assembly that you want to call. So and they have to have this native keyword. So we'll declare that, authenticate with username and password. And in our main method, we will create a new instance of our class first. So new authenticator. And then we'll call the authenticate method. And we pass in the first two arguments from the command line. Okay, and then we'll store that in a parameter, and then we'll say, so if we're not valid, if we didn't authenticate, we'll exit with an exit code and write to the standard error that it was not valid. And otherwise, we are successful, we have the right username and password, and we write out that it was valid to the standard output. So that's all we need there for the Java. Okay, so we're back in the Visual Studio, and now we need to add the C++ project. And first of all, we need to make the project aware of the header files for JNI. So we add the include library. We add the header files from the include folder in the Java JDK. So let's see if I can remember where that is. So that's on the program files, Java. There it is. Include. And you notice that inside the include folder there's a Win32 we need as well, so we'll copy that, go back and add the Win32 folder as well. Okay, that was the header files. And we also need the libraries, so we go back to the Java JDK, and it's in a folder called lib. There it is, and we don't need anything under that. Okay, so that's it. So now our C++ project knows about the JNI stuff. And the next thing we need to do is we need to add a reference to our C# project. So you can see the external dependencies, we don't have that there, and you might think you can add it there, but you can't actually. You have to go to the project and then say add references. It's a little quirky. Here we go. references, add new reference to a project. Here we have a sharp authenticator, we check that, and now we see that we have the sharp authenticator referenced. Alright, that's good. So we know that we need to use some of the native string handling, and we'll also need to use the CLI text encoding. So we'll add those there. So this is kind of a mix. It looks like a mix of native and CLI coding here that we recognize the using statement from C#. I'll start by creating a method here. The authenticate method returns a bool. Now, because it's native code, our username and password are constant character pointers, so it points to a location in memory where we have characters lined up in an array, and from here we will call the C# code. So we'll say sharp authenticator, and C++ should do : as namespace separator, and also as separating and calling a static method. So sharp authenticator : authenticator : authenticate, and then we have to pass in our username and password strings. We can see the signature there. So there we go. And that doesn't work because the C# code wants you to pass in the CLI string class, and we have the native constant characters now. So I'll create a method here to convert this. Unfortunately, there's no out-of-the-box way of converting it. We have to do that ourselves. So we're passing in the characters, and so that's the method declaration toString. Will wrap the username and password in toString in the authenticate method. And now we can see that that method compiles without any errors. Okay, so now so how do we convert from a constant character pointer to string? We need the length of the characters first, and we'll use the strlen method from the string implementation of C++. So now we know how many characters we have, and now we need to create an array of unsigned characters, because that's the only thing the CLI implementation can figure out how to use. So array of unsigned characters, and then we have to use the gc new, which is kind of new, but with garbage collection of an array, and we indicate the size as being the length that we just found from our constant characters. Okay, so now we have to iterate over each character and move it from one array to the other, from the constant characters into the unsigned characters array. So that's just a simple assignment from one array to the other, indexing with I. Now the string creation from the unsigned character array, we can use the encoding, the UTF-8 character encoding. get the string, passing in the unsigned character array. Sorry. Something wrong here. Oh, it's because it's not a static method. Let's see. Get string. Yeah, here we go. So now that's in place. Everything compiles. Very good. Now we need to generate the headers for JNI, and there's a command called Java H we can use for that, and we specify the class path and the output location and what classes we want to do this for. So here's the command line, we execute the command, and there we go. Now we go back in our Visual Studio project, and we can add that as an existing file now. Okay, there it is, and it's named with the full namespace package name of the Java class, and the dots are replaced with underscore. And so here's the signature of the method. Let's first include that here, include the header file. We'll copy the signature and put it in our code file. And we just need to fill in the names of the parameters, method arguments. So the first one is the environment, the Java, basically the Java runtime, and here we have the class that we come from, the Java class, and here are the two parameters, so username and password. So the Java runtime environment and the Java object are always passed in as the first two arguments. So now we have JString, and we need to find a way to get from JString to the native constant character array, and so there's a convenient method here, getString UTF characters, we can use for that. And so it takes a J boolean, tells it whether it copied or not, so we'll define a J boolean so let's say is copied, or is copy username. Okay, and there's an error there, and that's because we just have to define J boolean, not J boolean point or dereferenced. Here we go. Okay, so that's that. We should assign that to a variable, so constant character array, and we'll call it C underscore username. So that's our native username variable. That's fine, it all compiles. Let's copy that whole thing because we have to do the same thing for password. So it becomes is copy password. C underscore password. Okay, that all looks good. So now let's call the authenticate method, the native method. So we return authenticate of our two the C underscore username and C underscore password. And and that should be all well and dandy, except that now we have some native code here, so we have to be careful that we clean everything up. We don't have garbage collection for the native part of it, so actually the constant characters arrays that we are creating here, we have to clean those up, take those out of memory, otherwise we get a memory leak. So there's another method on the JNI environment we can call release. Release string UTF characters. Yeah, now we have to do that for both the username and password, and we specify both the DA string and the constant character pointers that we used. And you probably would want to wrap this in some try catch finally way to make sure that you always clean up. I'll just skip that step right now for simplicity, and that's it. So when you create this JNI proxy, there are a couple of things that you have to remember always. So the C# assembly has to be put in the same folder as Java, Exa. The C++ assembly has to be in a library path, and the architecture must match. So you can't call between 64-bit and 32-bit. Okay, so let's make sure we have those things in place. On our C# project, let's see, we have any CPU, that's good, and we output to the bin folder of the JDK. That's where the Java exe file is. And then for the C++ project, we will output to where we have our Java project, because that's in the library path of our Java project. And it's a 64-bit project, and so any CPU and x64 works well together. And our Java JDK is 64-bit as well. So that all matches. So we don't have to do the C# to be x64 specific. Any CPU will work. But for the C++ project, we have to specify that it's x64. Now back to our Java code here. Let's try and see what happens when we run this. Uh-oh, we get an error. It says unsatisfied link error. No authenticator in Java library path. And when we look on the left side, we say authenticator. Is that right? No, actually we changed our minds when we wrote this. So the actual name of the assembly is C++ or CPP authenticator. So let's correct that. Now that's correct. Let's see what happens now. Get another error saying that the yeah, that's because we didn't actually specify any arguments on the command line. Let's try and do that. So we'll specify the username as user and password as password. What's the pass or password? Password not valid. Did I specify that wrong? Let's go back to our C# code and see. Okay, so it has to be user and pass. Okay, let's correct that. So actually now we tested also that it could, fail for the wrong password, so that's not a bad test. So now it says valid. Okay, everything works fine. So this was the you see we have the C++, the CPP, the C++. Yeah, okay, so let's try and do the JNI for net approach. And here we'll call proxy gen. We specify the work. Let's see. Yeah, so we specify the location of our C# assembly. Remember, we put it to the bin folder of the JDK, and we specify where we want the generator files to go. We want those to go into the our authenticator project in Eclipse. I noticed that I took the C++ assemblies away. Okay, so now we have that run. We generated. So we don't have any C++ code that we wrote here now. So we refresh that and we get two new folders, CLR and JVM, where the JNI for net generated these files for us. We have the Java authenticator that it generated for us, which is basically the wrapper to call JNI. And we have some C# wrapper if we want to go the other way. We don't need that for this example. So this would be if we want to call the Java code from C# code. It generates both ways by default. Then we have this build file, batch file, that we can run to actually compile the generated Java code and the generated C# code. And since I don't have Java C and CSE, those two compilers on my path, I have to change the path environment variable when I run this. Let's get back to that. So here, this proxy generator XML file specifies, what it did. So let's correct the path, environment path variable. We'll do set path. Let's see. The target is fine. We want the Java classes to be generated into a different folder than our bin, because we don't want it to be. It has to be put in a separate jar when it compiles. So. Okay, our path here points to the JDK bin and to the Microsoft.NET framework. So now we can go ahead and try and run that build command. So the proxy gen, you only have to run once when you write your code. Okay, so now we ran the build. That was fast, and we get some extra things here. Now we get a DLL and we get a jar file. That's the JNI proxies that were now generated for us and compiled for us, and we add the jar file to the build path or the class path in Java. All right, and let's see how we can call our C# authenticator code through JNI for net now. So we create a new class for that, and we will call that JNI authenticator, or JNI for net authenticator rather. And we're at the main method again. Okay. We have to add the JNI for net jar file to our build path as well. Okay, there it is. And another thing we need is that we need all the JNI for net binaries in our library path, the Java library path. So since we know that our current folder is in the library path, we're just gonna put that where we have our Java project. In practice, you would have that installed somewhere, and you'll make sure your environment is set up correctly. You wouldn't necessarily copy that for every application you want to run. That wouldn't be practical. Okay, so it's all set. Now we just need to use this class called bridge, and we'll set verbose so that we can see exactly what's going on in JNI for net implementation. Let's see, why doesn't it pick up on that? Maybe Eclipse is just slow. It should be realizing that I have it on my class path and propose to me. Let's just try and find it out. Maybe it wakes up. No default values. Oh, here we go. Sometimes a little slow in compiling. Verbose, set verbose. Okay, so now we have verbose. We get some extra information, and we initialize the bridge. So the bridge class is basically what accesses your proxy. We have to indicate where our proxy assembly is, the one that was generated for us. So say a new file, and it will be in our current directory, so we just specify it without any path. So sharp authenticator dot j4n.dll. So that's not our C# assembly, it's the proxy assembly that was generated for us by JNI for net. Let's add that exception there. Okay, so now we say bridge, and we need to load that. There's a load method, load and register assembly from a file. Here we go, and now it all compiles, no compile errors. Let's try and run that, see what happens. Yeah, we see that we get it loaded and no errors, so we're good so far. And now all we have to do is actually just call the generated Java code. So authenticator, wait a second, that's the wrong one, because we called our other class authenticator. So we have to specify the whole namespace, so we'll call sharp authenticator dot authenticator, there it is, and authenticate, and we'll pass in the command line arguments, username and password. And same as before, we will validate the result of that call and exit out if it's not valid. So if not result, so if result is true, then it's valid. Otherwise, we'll write to the standard error saying that it's not valid. Okay, let's see what happens when we run this. We get an error. That's because, of course, we didn't specify the arguments, the command line arguments. Run configurations, arguments. Yeah, it's a different run configuration now than the other one, so we have to specify that again. User and pass. It's the right class we're calling, JNI for net. Yeah, run. And now we get another unsatisfied error. Why is that happening? So actually that's because, yeah, so the JNI for net is not in the right location. We have to specify the one that was in our project here. So add that to the build path. Take that away. Let's try and run again and see what happens. And now it's valid, it's working. So now we see that all we had to do was write our C# code, we have our Java code, we ran some proxy generation and compiling commands. So no writing any proxies manually, it's all done for us. The simplest possible way of integrating Java and C#. So that's it, thank you.